off. This finishes off our limits and continuity and differentiation. This is 2003, problem 13. So what we did yesterday, and I didn't give you the choices here. So Adam, it says the graph of the functions given above, at which values of x is the function continuous but not differentiable. Okay, it's got to be continuous, like you guys said. I have to be able to draw this without lifting my pencil. It's continuous everywhere till I get here, but it's got to be continuous, so I'm not going to look at that. This is not continuous. So where's the point where it's continuous, but you still can't find the derivative? Hey, now how long does that take to do that? 2 seconds. There'll be other problems that will take longer, as you saw yesterday. Okay, so now let's look at this problem. This is pretty typical. And by the way, I picked these problems because if you go to 2008, you're going to find one kind of similar to these two. Because there are certain problems that are repeated. They might be changed a little bit. This is 2003, number 20. Now, what I do when I have one of these 1, 2, 3s is I don't even necessarily look at the question because I don't want to get it wrong. Because the question says, let f be the function given above. Which of the following statements are true about f? They might say must be true. They might say are not true. So what I do when I do the problem, when I know it's going to be true or false, is I look at each statement and decide if it's true or false. Then I go back to the question and make sure I answer the question. Because if it said which ones must be false, that's a different answer. So often you can get this wrong because you just didn't read the question correctly. So if I write true or false here, at least that lets me take that part of the thinking out and just worry about what the question's asking. So there's my function. It's a piecewise function. I guarantee you will have piecewise functions on the exam. That's a guarantee because they said students don't do well with this topic, and so they will continue putting it on the exam. So you know that's going to happen. Okay, so the first question is, what about the limit of f of x? Well, I got to find it. No, you don't have to show work on the exam. You do my little quizzes. And I have to look at the limit of f of x from the left, and I have to look at the limit of f of x from the right. Remember? You got to check from both sides. Now, from the left, I'm going to use this function, which is x plus 2. So what is that going to be? It's going to be 3 plus 2. That's 5. What about from the right? I'm going to use the other function. So it's 4 times 3 minus 7. 12 minus 7 is 5. Now, by the way, I have seen a problem like this in the free response. And you would have to write all of this out. You have to say the limit from the left equals the limit from the right, and which they do. So this is true. Remember, we don't care what happens at 3. Now, for continuity, remember there's one more piece. The limit has to exist. F of 3 has to exist. What is f of 3? Which equation am I going to use? The top one or the bottom one? The top one. So it's going to be 3 plus 2, which is 5. And for continuity, then I need to have f of 3 has to equal the limit as x approaches 3 of f of x. And you better give the reader numbers if you're talking about an FRQ. Because they're not, you might look at it and say, oh yeah, I can see they're equal. We assume nothing. I would say 5 equals 5, so yes, guess what? That is true. Is the function differentiable at 3? Well, what's the derivative of this? I can write another piecewise function, f prime, if I want to. What's the derivative of the top function? 1. And the derivative of the bottom one is 4. And for a function to be differentiable, those two numbers have to be the same. The derivative from the left has to equal the derivative from the right. So is that true? No. Now, if the question had been which one of the following statements is false, I would answer 3. So this is why I do this first. Then I worry about what the question says. And it says which one are true. And some of them might be which ones might be true. So read the question carefully. This one's just true. 1 and 2, and you know that will be a choice. Another choice would be 1, 2, and 3. So I love these. No, you don't like these problems, do you? They're very common on the SAT. Okay? Any problems with that? Okay, we're going to go ahead and do another problem. And we're going to get out. You should have your packets out. You need paper to write on. There is not enough space. No, we're going to do free response. I'm going to make that bigger. better. And that's question 5 out of 2010. If we get to 2011, fine. Not a good quality problem, but it's okay. We'll deal with it. And honestly, the very first question is really important. And if you take this blue sheet, you will see overlaps, of course. It's off-white, it's a beige packet. You'll see overlaps, but you'll see this thread all the way through every single year. So you know it's going to be on there. No, it's the right color, but it's the wrong one. And I don't have the extra ABs, I have the extra BCs. Now, do you remember what I said 2 days ago? I said when you come into a free response problem, read the question and look at the picture. Are we given the function or the derivative? Okay, what I would do, you cannot have colored pencils or pens on the exam. I know, or highlighters. I don't know. But you can't, and you can't bring in water either. You can have nothing out except your pencil and your calculator. You can bring water for your breaks. But I would write at the top of my test paper, derivative. Because you can come back to problems. You can come back to problems. You don't have to read that thing again and say, oh, yeah, that was a derivative. So I want to make sure I know that. I had a thought. Okay, what's the other thing you're thinking here? Look at the picture. Hey, guys, look at the picture. What do you see? I see piecewise functions, but what's the shape? It's a circle. Okay, the minute you see nice geometry figures, you better be thinking you're going to find the area. Okay? On the exam, you are going to have a booklet. And in the booklet, because you probably haven't seen these, if there's parts, A, B, C, D, it might do 1A, 1B, it'll probably just do B, and then C, and then D. If you answer the question to A in part D, we will not read it. We do not read forward. If you put everything here in A, then we will read the whole thing. So make sure you get the pieces in the right place. And I don't really want to see you push everything in A because then it'll be too hard for us to read. But if you do that, if you answer D in the A part, it's okay. But if you answer A in part D, we will not look at it. That's just the way it's done. It's the consistency, probably. So that's what the blue books are going to look like. They're booklets. You just open them up. The diagram, I believe, I'm trying to remember if it's in the book. I don't remember. And I did grade this one, I think. Okay, so we want to find G of 3. I like to take the information out of the reading. Okay, so first off, that's G prime. I'm really going to make sure I know that. And it says it's on a closed interval, which tells me maybe I'm going to do max-min existence theorem anytime you close the interval. And it says G of 0 is 3. It's very easy to miss. Oh, sorry, 5. I can't read that very well. This is not a good copy, but that's okay. It's 5. It's like 3 to me. And it says the graph is the derivative, and it even tells you it's a semicircle, and that these are line segments. So you don't have to assume anything. And it says find G of 3. I guess we could put it right here. So this is what I want to find. Now, I don't want G prime, I want G. So what are we going to do? Okay, if you're given the derivative and you want the function, you know you're going to have to integrate. Well, as I was helping second hour today, I realized that they don't remember the fundamental theorem of calculus, so we better review that. In fact, I think I might even put it on another page. The fundamental theorem of calculus. Remember that? If I integrate from a to b of little f of x dx, do you remember what that is? I didn't prove it to you. There's only like 4 theorems. This is one of them. F of b minus f of a. And now, what does this integral represent geometrically? The signed area under the curve. So we do have to worry about the sign. Okay, I think that's going to help. And you are going to have a problem that does this. And it's going to help you throughout your entire exam because it's really hit on hard. In particular, I don't have f of x and capital F of x. I have this. I have the integral of g prime of x dx. What's the antiderivative of g prime? G. And if I have a definite integral, if I don't have a definite integral, I do have to add plus c. But if I have a definite integral from a to b, that would be evaluating this at a and b. So this would be g of b minus g of a. And this is just the area from a to b. And I'm looking at that picture saying, I can do that with geometry. That's pretty easy, right? Except I have to figure out what a and b are, don't I? So I want one of these points to be known, and the other one is what I'm trying to find. So if I integrate from a to b of g prime of x dx, I would like to see you make sure you put the differential in there, but it will not be marked wrong if you don't, is equal to g of b minus g of a. And I want to find g of 3. What do you want a and b to be? Why 0? Because we know that point. I could go from 1 to 3. You're not wrong, I just don't know what g of 1 is. So if I integrate from 0, because I know that, and 3 is what I want to find, so I would study this type of problem probably Tuesday night. If you want to look over something, this is one you're going to see. It'll be in different context. Actually, this is not even in a real context. So it's g prime of x, which is equal to g of 3, and I have an equation, minus g of 0. G of 3 is what I'd like to find, right? And what's g of 0? 5. Well, that's kind of nice. So this is minus 5, g of 3, and now all I have to do is find this area. You get 1 point for finding the area, I believe. We can look and see the scoring. This is worth 3 points. Only 1 point for using the 5, by the way. And then 1 point for finding the area, and then 1 point for the answer. Okay, so the area is going to start at 0, right? I'm going to start here and go over to 3. So I want this area. So I want just this part. You guys can do that. That's easy. No? What part of a circle is that? It's 1/4 of pi. What's the radius? 2 squared plus 1/2. Base is how big? 1, and the height is 3. So if I solve this equation for g of 3, and I'm sorry I don't really have a lot of space. That's why I said you can't really write on here. G of 3 is equal to 5 plus, and you don't have to simplify that if you don't want to. I'm going to, because it'll bother me if I don't, because that's just pi plus 3/2. Do you have to add the 5 and the 3/2? No. Can you leave your integral as an integral, or do you have to actually do it? You have to actually do it. But once you get to the arithmetic part, you can just leave that. And I highly recommend you do that. So can you find g of negative 2? What's that integral going to look like?
Wait, so you have a whole 2-page slide for every question?
Yes, which is nice. You have 2 pages laid out for every question. So you have lots of space. Write something down. If you leave nothing, if there's nothing there, you know what's wrong. So how would you find g of negative 2? Now be careful. This is still a, g of negative 2. Well, I'm going to integrate from where to where? Negative 2 to 0 is probably the easier way to do it. Could you do 0 to negative 2? Yes, but then you're going to have to remember the negative sign, right? Because you're going the wrong direction. We always want to go left to right. And that's going to be this area. Well, that's pretty easy, right? Of g prime. Now, what do you have to show in the exam? I really think to get full credit, even though you might have the right answer there, if you just come up with this answer, 5 plus pi plus 3 over 2, you're going to get nothing. Absolutely nothing. You better write how you arrived at that, which would be at least this integral. They will not give you points for not supporting your work, even though you don't get a point for that. So this is what? G of 0 minus G of negative 2. So you guys find it. And whoops, I know I have answers here. Can't read that. That's kind of nice. Can't read that very well either. I could go back and rebuild it. So you get 1 point for G of 0 equals 5. Christian, put your phone away, please. I know, I got to get a clock.
So with the problem A with G of 3, just leave it as 5 plus pi plus 1.5.
Yep, that's fine. Nope, I wouldn't add it. Because it kills us when you add it wrong. We go through and everything's right, and you add it wrong, and we go, oh, we got to take the point back. Don't make mathematical statements that are not correct. That's going to be another thing. So, did you get G of negative 2 is 5 minus pi? Okay, we've got 1/3 of the problem right. Now, this concept here of adding the 5 plus that, you've seen it many times. You saw it on that multiple choice test yesterday, didn't you? Do you remember that problem? It was on there. Okay, that concept is embedded throughout the exam. So Mrs. Hersman and I are going to hit on that and hit on it again. So we got to get you to get that. Okay, what's the next question? Oh, I love this. Inflection points. Justify your answer first. Why? Where do you find inflection points? We just did this yesterday. Second derivative changes sign, right? And we're on the open interval. So G double prime has to change sign. I got a point. Because I justified my answer. And what is G double prime? That's the slope. That's going to be the slope of this graph here. Okay. And it says, I want to find all of them. Now, do we care if the second derivative is 0 or undefined? It doesn't make any difference. So let's look and see what we get. The slope of this line is positive. Guess what? It's still positive. It hasn't changed sign. There it is. So where is that? X equals 0. And then I'm going to come down here, still negative, and becomes positive. That's at what? 2. Any more? Positive. Is that not, even if you couldn't do A, can you do B? Sure. And that was where? 3? That should be right. Let's check. I believe it's 2 points. I'm gonna guess that. Okay, 0, 2, 3, because G prime changes from increasing to decreasing, it's easier to say second derivative is changing sign. It doesn't matter. That confuses me. That makes me think harder. I don't want to think hard. So it's 2 points. So now you are more than half. And if you go to the website and you look at the average scores, the average score, and this is probably, I'm going to guess, probably no better than 3. This is nationally. And we got 5. We will do better than the national average. We always do better than the national average. I can dig out my results from previous years and I can post them. I can't put individual scores up, but I can post the results and you'll see that we're always better than the national average. I gotta go find them. Oops. Okay. So if you get 5 out of 9, you're looking at a 4, possibly a 5, as long as you're not leaving something blank elsewhere. If you can get 5 out of 9 on every single problem and do well on the multiple choice, you're looking at a 5. Okay, what's the next question? Oh, this one was kind of hard. I thought this was hard. Okay, h of x is g of x minus 1/2 x squared. So I'm going to write that down so it's there. So C. G of x. Now, I can't say that you're going to do all this one problem is going to be just this one topic. It's not. It's all blended with all sorts of topics. So that's the problem with this. We've already seen the fundamental theorem in here. I want h of x. And then what we do in study sessions is you come with problems worked out or problems that aren't worked out, and we work them out or we find out where the problem is. There's also 0 hour. Mr. Dahman will be doing 0 hour. And I'm still here too during 0 hour, but he'll do a study session during 0 hour if you have conflicts with the evening sessions. Okay, find the coordinates of each critical point of H. What is a critical point? Remember, we did this yesterday. H prime equals 0 or undefined. Okay. It is at endpoints if we're looking for a max and min. Oh, now this is talking about relative minimum, relative max. So I'm not going to look at the endpoints. Locals do not occur at endpoints. They actually can occur at endpoints, but for this course we're going to say they can't. So we don't have to worry about the endpoints. Or neither a max or minimum. Okay, so I need to find out whether this derivative is 0 or undefined. Okay, so h prime of x is equal to the derivative with respect to x of g of x. Oh, this is easy. Minus the derivative with respect to x of 1/2 x squared. What's the derivative of g of x? G prime of x. That's just too easy, isn't it? What's the derivative of 1/2 x squared? X. Remember how hard that was in the beginning? And how easy it is now? This is the beauty of the review sessions right now. Because when you walk out in May, you will have reviewed everything. You'll have those connections that we can't make during the year. And you can look back and be proud of what you've learned. Because you've learned a lot. Okay, I want to look where this is 0 or undefined. Why this was hard is because I didn't really expect you guys to have to do this. Actually, there's a couple ways you can do this geometrically. So when is this 0? It's when g prime of x equals x. And is g prime of x ever undefined? No, it's fine. So I'm just looking for the 0. I believe you get a point for that. Well, I want to find out where g prime of x equals x. Let's do it graphically first. I want to graph y equals x. That's, whoops. That's y equals x. Helps if you do it in the right place. So there's one place where y is equal to x. Where is g prime equal to just x? It's a 3, 3, right? So x equals 3, but there's another one. Where's the other one? It's right here. You can use geometry to find that coordinate if you'd like, or you can use algebra. Can we write the equation of that semicircle? So you do have to know the equation of a circle. It's x squared plus y squared equals r squared. And the radius was 2. So you have to solve a non-linear system. And I want y equal to x. That make sense? Okay, so I'm going to put y equal to x in here. So I'm going to get x squared plus x squared equals 4. I get 2x squared equals 4. So x squared equals 2. So x equals square root of 2. Or negative square root of 2. Why can't I have the negative one? Look at your picture. It's only the top half of the semicircle. The bottom half would give me the negative one. So you have to look at the geometry of it. So we get to throw that one out. So the answer is x equal to 3 or square root of 2. Question? Ask me what? A lot of I graded this problem. A lot of students gave me the negative answer. Can't be. I think even I did that. Okay. Those are my critical points. I had to look at the question because I forgot the question. Because y is equal to x. The equation of this line is y equal to x. So your system, I should have written this, is x squared plus y squared equals 4, and y is equal to x. That, you want to find out where those intersect. You could do it geometrically if you want. Because on the circle, let's see if I can draw this, because my picture was so bad. I want y equal to x. So these are equal. What kind of triangle is this? It's an isosceles right triangle. Do you remember how to do these? If this is x, then this is equal to x times the square root of 2. Gives you an equation. 2 equals x square root of 2, because I bet there's some geometry people in here. right? Anybody think right doing geometry instead? Still some algebra, but the algebra is a little easier. Divide by the square root of 2. And your answer at 2 divided by the square root of 2 is fine. That is acceptable. You could go to decimals if you'd like. But just so you see that it's the same as the square root of 2, let's rationalize this, because you might be saying that's a different answer. Is it? I get 2 square root of 2 in the numerator, and I get what in the denominator? 2. Oh, it's the same answer. Which way do you like doing it? With the geometry or with the algebra? But some of you may be thinking more geometrically and say, oh, it's an isosceles right triangle. I got to figure out what these legs are. But it's still algebra. Okay, now those are our critical points. Okay, here's where I think I'm going to have to use a second derivative test. Okay, Adam? Because x is 3, I could do it either way. Well, I think a second derivative test is easier. You can test your interval, your points around the 3 and the square root of 2. That seems too hard. What's the second derivative then? H double prime of x is equal to what? G double prime of x minus 1. Do I have G double prime of x? Okay, so I want to find H double prime, let's do the easy one, of 3, which is equal to G double prime, it's the slope at 3, minus 1. Uh-oh, that's not going to help me. What's the slope at 3? It's undefined. Okay, I guess the second derivative test is not going to work. Square root of 2 will work. Yeah, I think I'd do a first derivative test, because you got to find out if it's a max or min, right? So, which is bigger, 3 or the square root of 2? These are the zeros. Then you have to test other places. Okay, now this is G. So I'm looking where the first derivative is 0. So this is G prime. And I have to see what the derivative is doing. So what's G prime of 0? H prime of 0 is equal to G prime of 0 minus 0. So I just need to know if it's positive or negative. What's G prime of 0? 2. So that's positive. Do you guys know how big this is? It's a 9-calculator problem. Oops.
How big is what?
Square root of 2. It's 1.4. It's close enough. So what number would you choose in here? 2. So I would need to find H prime of 2, which is G prime of 2, minus 2. So what's G prime of 2? That's 0. Well, this isn't that hard. It's 0 minus 2, so that's negative. Okay? So is this a max or min? Well, my function's going to increase. Now, I don't need the second derivative to get the concavity because this is 0. This is increasing, decreasing, so I know it looks like that. I mean, I know it looks like that there. So this is a max or min? Max. Because H prime goes from positive to negative. You have to justify.
You subtract 2 because the 2 is the x.
Yeah, because it was H prime of x equals G prime of x minus x. So let's take a number to the right of 3. Let's take 4. So H prime of 4. Personally, I suppose you could think this through, but I think I want to show the work. What's the slope at 4? You don't have to do it at 6. Because what's the slope at 4? Is it positive or negative? Negative. And then you're going to subtract 4? So what's going to be true about H prime of 4, positive or negative? It's negative. So now what's going to happen to my function? It's going to keep decreasing, level off, and then decrease. So you have a change in concavity there. So you have a max at, I better say where, x equals square root of 2. Did it ask for the where or the what? I got to go look. Find the location, so it's the where. Okay, shall we see if I got it right? I haven't done this problem for 2 years. No, I probably did it last year. Okay. H prime of x, so you get a point for this. That first thing that I said was g prime of x minus x. You get a point for finding the two candidates, so if you only found one, you didn't get the point. And the answer for the square root of 2 with the analysis, which just says this is a maximum, because they say h prime is positive, and then it becomes negative. And h has neither max nor min at x equals 3, because you know what I forgot to do? I forgot to justify my answer. Well, that won't count. Neither, I forgot to answer the question. At x equals 3, there is no sign change in G prime. Now, my work's a little sloppy, but will I get full points? So if we go back here to the scoring rubric, where'd it go? Okay, I think you should be able to get this point. That one's tough because I really didn't think they were going to make you something that's so hard as that circle. But so you're looking at 6 points out of 9, and you know you even get this one. If you see the 3 and you say it's neither, but the problem is without the square root of 2. Let's go back and look at my sign chart. If I don't have the square root of 2 identified in my sign chart, I easily could pick 0, and it's going to go plus to minus, and I'm going to get a max. So if you have to find these points, I would be relatively close to that 3. So you don't pick something over here which will make it look like a max, but it's not a max. Okay? It's not that bad, though, if you look at it. 15, but don't forget I'm teaching. Yeah, 15 minutes each problem, because I'm teaching it. Okay, so let's go ahead and let's bring up 2011. Yeah.
Say we answer A and B, but we're not to see how many points we say we get.
If you answer just A and B, you're going to get 5. Out of 9. They're all 9. I don't know why they're 9, but they are. Let's say you can't get A, but you get B and C. That's okay. No, so don't stop. If you get stuck on A, don't stop. We might be able to do B. So let's do 2011. I'm going to bring it up. 2011 was, what are we looking for? Number 4. This is last year's. I don't remember it. Oh, this was a great problem. I like this problem. I always say that. I say everyone. No, there's some I don't like. So there it is. Can we take a picture? Do you guys find it?
Wait, which one?
2011, number 4. And I want you guys to try it. And you may not remember mean value theorem, so we may not be able to get D.
2004?
2011, number 4. Oh yeah, I've done this problem. I remember this. You should be able to do A, B, and C. You might not remember mean value theorem, so that could be a problem. Now this year they're not going to release all the free responses. It's going to be way different. And when you look at the picture, again, I'm going to look at the picture. Is this a derivative or is this f? But be careful. It's f, but then when I read the question, g of x is the integral. So if g of x equals 2x, yeah. equals 2x plus the integral from 0 to x of f of t dt, what's g prime of x? 2 plus the derivative of an antiderivative. This is the other half of the fundamental theorem of calculus. And you will see it. What does a derivative do to an antiderivative?
It cancels
So what's g prime really equal to? It's equal to 2 plus f of x. So actually, f of x is the derivative. It's part of the derivative of g. And that makes this hard. It's a lot easier without the 2x there. Okay, I'm going to let you guys try those. I'm giving you a lot of hints because of this. And I'm going to hand back your quizzes.
We should just get little earpieces for the whole class.
For what?
Everything is telling.